Welcome to the Introduction to SAS tutorial. In this tutorial, you'll learn the basic features of SAS. The SAS window is comprised of 3 separate windows, and it actually has its own Windows bar along the bottom, just like Windows 95, 98, and Windows XP. The main windows that we're going to be interested in using are the log. The log will tell us where we've made mistakes when we've programmed our code. The editing window, which is where we will actually enter our computer code into in order for SAS to execute them, and the output window. Now, the output window right now doesn't have anything in it. So if you're interested in what the results of your analysis are, the output window is where you will go look. The log window will tell you whether it was executed successfully, and the editor is where you will actually enter in the computer code. Now on the left side, you see there is what's called an Explorer window. And this is where you can go and look for data sets. For example, if you go under Libraries, under Work, you'll see that there's an airline data set. So if I click on it, you'll see that I have in this data set, it's showing me 1, 2, 3, 4, 5 columns, and you can see the various data in those. So this is a way you can make sure that your data is imported correctly. Also under the Explorer tab is a Results tab. Once you've run several scripts or computer codes, you might want to be able to organize the results and to be able to navigate through the output window effectively. And that's essentially what this window will allow you to do. Let's start off by typing in a simple program that will do nothing but print out our airline data set to the output window. Proc print is the procedure that we'll use. We need to type in the data source, where the data is coming from, and then every line needs to end with a semicolon. So I put a semicolon, then I need to type in run and put a semicolon. Now when I do this, SAS doesn't do anything. It's just putting it into the editor where SAS could eventually run it. In order to run this code, you need to go up to the icon that looks like a little running man, and it's the submit button. If you click on that button, that's what will execute your code. So if I click on it, notice that my output window pops up, and in my output window I can see all of my data. It gives me information about when the computer code was run, tells me what the observation number is, the variable, each of the variables, and the values associated with each. And it prints it to the output window. One misconception is that proc print will print to the printer. It does not print to the printer, it only prints to the output window. If you wish to print this, go to the output window and simply click on the print button, and then that will initiate the printer to actually print what's in the output. Notice over in the results window, you see that there is results. Proc print was run using the SAS system, and here is, if you were to double click on this, what comes up is the beginning of your procedure that you just ran. Well, this is the introduction to SAS tutorial. Hopefully it was helpful. If you need to see it again, please run it again. If you have any questions, please ask. Welcome to the Introduction to the Data Step in SAS tutorial. In this tutorial, you'll learn how to manipulate data from one data set, change some attributes of the data, and export it to another data set. That way you can work with this new data set that has the attributes that you would like. I've already imported data in to SAS, and to the left in my Explorer window you can see there's a data set there called demand. If I open it up, you can see that it has price and demand, which is a simple economics example. I'm going to close this now. So you have two columns, price and demand. Well, let's look at price and demand. So I'm going to use Proc Gplot. My data that I am interested in is the demand data set. I'm going to plot demand on price. Notice that those were two columns in the data set. Demand was one column, price was another column. I'm going to run this. And don't forget your semicolons at the end of every line. Now, if you click the running man or the submit button, you'll get the picture. Now from here you can kind of notice that this has a non-linear attribute to it. This is not a straight line, even though you could visualize it and say, well, maybe that is a straight line. It's really not a straight line. So what we're going to do is we're going to go back to our editor. We're going to use the data step to hopefully straighten out the data. All right, the data step works by typing in data. Now this is the name of your new data set. So we're going to call it demand 2. Set comes next. This is the set which you are reading the data from. Okay, so this is demand. I'm going to make a new column. I'm going to call it LN demand. This will be the natural log of demand. Notice I'm putting semicolons at the end of every single line. I'm going to run this. If I just highlight what I want to run, it will run only that portion of the code. I don't have to run everything again. I can simply highlight what I want to run and submit that. So I submit it. It doesn't look like anything happened. But if I come over and look in my Explorer window, I see that I have another data set in here called demand 2. I'm going to open that up. Notice that demand 2 has the columns price and demand. Those were the same as what was in the demand data set. But in addition, it has another column called LN demand, natural log of demand. And you can see the values that are there, and they are out to a horrid amount of decimal places because SAS calculated those. All right, I'm going to close this now that you have some understanding of what this data set looks like. Now what I want to do is actually get a picture of it. So I'm going to do another Proc Gplot. My data now that I'm going to be interested in is demand 2. I'm going to plot LN demand versus price. I'm going to run. And in SAS, after using some procedures, it's helpful to have a quit statement. Otherwise, SAS actually keeps the procedure running, and it takes up some resources, and it doesn't allow you to look at your data and other problems. All right, I'm going to simply highlight this, because this is all I wish to run. I'm going to push the submit button. Push the submit button, and it looks like nothing happened. Well, isn't that the picture I had before? Well, if you look at the scroll bar here, you can see that there's another picture hiding under it. Now, if I look at this picture is a straight line. If you look at that. That line or that data looks very linear versus the old picture, which is here. So keep this in mind. The SAS data step gives you the ability to transform your data to do various things with it. You can add columns together, you can subtract columns, you can find minimums and maximums. You can do all sorts of things in the data step. This is supposed to get you an introduction to the data step and to give you some sense of how it works. So I'm going to go over this again. The first line is data, and that's the name of your new data set. The data set that we're writing the information into. Set is the old data set where we're reading the data from. Below that goes any particular commands that you want to execute to change the data set. And after that, you have the run statement. And also, don't forget your semicolons. Well, this has been the introduction to the SAS data step. If you have any questions, please ask or watch this video again. Welcome to the Import Data into SAS tutorial. In this tutorial, you will learn how to import data into SAS from an Excel file. To start, open up SAS, go to the File menu. Under the File menu, you'll notice that there is an option for importing data. So select Import Data. Once you do this, a wizard opens that will help you import the data. The standard default is importing in an Excel file. So I'm just going to simply click Next. Now a window opens up asking you where the file is that you wish to import. I'm going to browse. Use your directory structure to find it. It defaults to the SAS folder, which you may or may not have your data in there. I'm going to go to my personal directory, Courses, Stat 543. I'm going to open the headache file. This is a worksheet that has data in it, and it's easy to import. So I'll click Open. Notice that it fills in the box. Say OK. The next thing I need to do is tell it which sheet I want to import. In this particular data set, there's only one sheet, sheet 1, so I'm going to just click Next. Now I need to be able to name my file so that I can refer to it later. It's going to put it in the work library, and I'm going to call this data set headache to be consistent. Now that I've done that, I'm going to click Finish. Notice that SAS doesn't bring up the data set for you to look at. It just gives you a note in the log. It says, note, work.headache was successfully created. So we need to verify that the data is actually there. In order to do this, we need to use the library structure. On your left, you'll see that there in the Explorer window there is libraries. Double-click on libraries. Since this was in the work directory, work.headache, click on work, and there's our data set, headache. And I can open that up. Notice a window opens up with the data in it, with the appropriate column headings, and I can scroll down to verify that all of my data is in here. Well, that's it. It's fairly easy to import data into SAS from Excel. If you have any other questions, be sure to ask or watch this video again. Welcome to the Proc Univariate tutorial. In this tutorial, you'll learn how to use the basics of Proc Univariate and understand some of the output. Proc Univariate is a very useful procedure, and throughout most classes that you would take where you do statistical analysis, Proc Univariate is one of the most widely used and most easily accessible SAS procedures. So, the first thing I'm going to do is start by typing Proc Univariate. Now, with any procedure, you always have to tell it what data set to look at. So I'm going to go over here and look through my Explorer to see what data sets I have. And in the work directory, I have one called CRISP. So I'm going to use that one. SAS is not case sensitive. So what I like to do when I write my scripts, and this is a good tip for other people, is to capitalize anything that you don't need to change between runs. For example, if I want to have a different data set, all I need to do is change the lowercase CRISP to my new data set, and everything else stays the same. So I'm going to use that as a convention. So the variable I'm going to look at is VAR. I capitalize it because it will always be the same. The variable in that data set is called crispness that I'm interested in. Then I simply type run. Notice that I always have a semicolon at the end of every single line. This is very important in that if you don't have it, SAS will essentially blow up, yell at you, tell you that something is wrong. So you must have those semicolons at the end of every single line. All right, now that I've typed this in, let's see what sort of output we get. Okay, immediately we see that the output window has been popped up and the end of the output is shown. Okay, so it says the SAS system gives you a time when the procedure was run, which procedure you used, which variable you used. I used crispness. Tells me how many observations there were. In this data set, there were 45 observations. Its mean is 37.77. Standard deviation of 2.087. Gives me skewness statistics, corrected sum of squares, coefficient of variation. Gives me some weights if I were to have a weighted mean. They add up to 45. Some of the observations, if I were just to add up the data before dividing by 45, gives me a variance, kurtosis, corrected sums of squares, and standard error of the mean. And again, in addition to this, it repeats the mean down here, gives me the median. This data set doesn't have a mode, so it leaves a dot there because it doesn't have one to provide. The standard deviation, the variance is there again, gives me the range and the interquartile range. It does give you a statistic down here or a test for a hypothesis that your variable is equal to 0. For most people, this is completely useless. So I tell people just to ignore this part of the output. It gives you quantiles, the maximum, the median again, gives you the minimum value, gives you the first quartile at Q1 and the third quartile at Q3. It also provides what it calls extreme observations. Are they really extreme? No, they're just the ones on the end. It gives you the highest 5 values and the lowest 5 values. So it gives you some idea of what your data looks like. This is what this is supposed to do. It's supposed to simply describe your data. One other thing that you can do with Proc Univariate is generate a histogram. So if we go back to the editor window, add a line after VAR and type in the word histogram, put a semicolon, and if we run this, we'll get the same output again, but in addition to that, we'll get a histogram. And the histogram is very useful for telling us the shape of our data. How is our data distributed? Is it all close to the mean? Is it far away from the mean? How spread out is it? What shape does the data have? So keep that in mind. Many times you'll want to generate histograms, so this is a way to do that. Now, I'm going to close this window. We could go back to the editor window and notice that using my convention of always typing lowercase on the things that I want to change, that will make it easy for me to change my script later. Well, this has been the introduction to Proc Univariate. Welcome to the introduction to the output statement in SAS tutorial. In this tutorial, you will learn how to export various attributes from regression models into a separate data set, such as residuals and predicted values. Now, I've already imported the data in, and I've actually transformed it already. The data has to do with the price of an object and how much demand would be at that price. So I'm going to use Proc Reg since that's the data or the procedure that we're interested in. So Proc Reg for regression. Our data is equal to demand 2. We need a model statement. Our model is natural log of demand. Remember, I've already transformed this, so I have a variable called natural log of demand, which is ln demand against price. Now, the next statement that I'm going to use is the output statement. So output out equals. Now, this is going to be the name of my new data set. That's going to have all of the attributes that I'm interested in it. So I'm going to call this out demand. Why out demand? It's the output from the demand analysis. It can be anything you want. I just picked this. R equals resid for residuals, or you could write the whole word residual out. P equals pred for predicted, and it's going to put residuals and predicted in my new data set. The next thing I need to do is run this. But in order to generate the output into a data set, I need to put a quit statement. It won't actually finish that data set until it sees quit. So I'm going to submit this code by clicking on the little running man. And notice that I get the regular SAS output in the output window. I can see that my model has an R squared of 0.96, which is pretty good. It means it fits this data very well. I can also get the parameter coefficients, etc. But I'm really interested in looking at the output, like the predicteds and the residuals. And here's my data set by going to the Explorer window. I see a data set called out demand. If I double click on it, I see that I get a copy of my old data set. My old data set had the columns in it of price, demand, and remember I said I transformed the data already to the natural log of demand, ln demand. And then it gives me the predicted value of ln demand as well as the residual. Now I can use these residuals for various things, such as testing for constant variance, testing for normality of the residuals, which will be included in another tutorial. I'm going to close this. This has been the introduction to the output statement in SAS tutorial. If you have any other questions, please ask or watch this tutorial again. Welcome to the Creating Boxplots in SAS tutorial. For this tutorial, you'll learn how to create boxplots in SAS. Now, I've already imported data into SAS. In order to import data into SAS, you will need to go back and look at the imported data into SAS video, and that will show you how to import the data in. The procedure I'm going to use today is proc boxplot. Fairly descriptive. I want to create a boxplot, and this is the procedure that will do it. The data that I'm interested in is headache. I've already imported this in. Remember to put a semicolon at every line. I'm going to plot. In this case, in the data set, there are two variables, difference in relief and treatment. So that's exactly what I'm interested in. Now, if you have spaces in the title of your SAS file, okay, you created it in Excel and there is a space there, you're going to have to put an underscore in SAS in order to preserve that space. Difference in relief by treatment. Again, put a semicolon at the end of every single line. Then I'm going to run. I have to type run, but that doesn't actually run it, remember that. I hit the submit guy, and I get a box plot for my data set. Notice that for the box plot, it's giving me the difference in relief for each of these treatments. It shows me a box plot for each of the treatments. And I can use this to identify outliers. I could also use it to identify any differences that may exist among the treatments. For example, in this data set, it looks like aspirin produced the greatest difference in relief. Over here I have a control, so I have some reference to look at. So keep this in mind when you are looking at data sets where one variable is continuous and another is categorical. This will help you describe your data in a pictorial way. This has been the Introduction to Boxplots in SAS tutorial. If you have any questions, please ask or watch this video again. Welcome to the Introduction to Creating Scatterplots in SAS. SAS is a useful tool for creating scatterplots, and there are two ways to do it. I'll show you both ways, and you can decide which one is more visually appealing for you. For most people, the second one is the best way to do this. I've already imported some data into SAS. If you need to know how to do that, go back and look at Introduction to Importing Data into SAS video, and that will show you how to import the data in. Okay, so what I want to do is create a scatter plot. So I'm going to do proc plot. That is the procedure that will create a scatter plot. The data that I have is forest. Okay. Make sure you keep your semicolons at the end. Okay. Then I'm going to type in plot. Then I have to tell it which variables I want to plot. In this case, I want to plot height, HT, by DBH, which is diameter breast height. This is for a group of trees. We want to relate their height to how wide they are, or the trunk is, at 4 feet off the ground. Type in run, and we can run this simply by using the little run man up here that will submit the statement, and we can look at the output. Okay. Notice what SAS does here in the output window. It uses letters to create the picture. Now, for many people, this is very annoying. However, you can see a general pattern in this data. However, it's not the most visually appealing. So this is the method that we really won't want to use. However, you can use it, and there's nothing wrong with it. So what we can do is we can go back to the editor and change one thing. Instead of using proc plot, use proc gplot. So change the plot and the proc plot statement to gplot. Now, if I simply run this code, I get a new window that comes up. It's a graphics window. That's what the G stands for. And notice that the picture is much more visually appealing. It puts little crosses or plus signs where the observations would fall. This is your x-axis, this is your y-axis, and we can see that there is a relationship between the diameter breast height, or the diameter, breast height, and the height of the tree. So we need to be able to describe this relationship, and a scatter plot helps us to describe this relationship. This has been the Introduction to Creating Scatterplots in SAS tutorial. If you have any other questions, please ask or watch this video again. Welcome to the Introduction to Proc Corr in SAS. This tutorial will help you learn how to generate correlations for your data sets in SAS. Now, first thing you need to do is import some data. I've already imported data in, and in order to do this, if you need to know how, go back and look at the Importing Data into SAS tutorial. To start off, I'm going to use Proc Corr. This will give me the correlation between two continuous variables. The data set, I'm going to use the forest data set that I've already imported in. And the variables that I'm interested in the correlations are diameter, breast height, diameter at the breast height of the tree, and the height of the tree. I would like to know if these two things are related. How thick the trunk is versus how tall the tree is. I'm going to run this. Remember to keep semicolons at the end of every line. Go up here. The little running guy means submit. So you would just simply click this and you will get your output. Here's the output in SAS. The output is all text, similar to Proc UNIVARIATE. For each variable, it tells you how many observations there were over here under N. It tells you what the mean of each variable is. It tells you what the standard deviation of each variable, the sum, and the minimum and maximum. Down below, it gives you what's often called a correlation matrix. DBH correlated with itself should be 1. Height correlated with itself should be 1. However, when I look at DBH versus height, I see the correlation is 0.894. And below that, there is a p-value associated with this, and it's testing whether or not there's any correlation at all. And from the small p-value, you can see that the correlation is statistically significant. If you haven't discussed hypothesis testing yet, don't worry about this portion of the output. The main portion of the output that you'll be interested in, if you're simply interested in estimation, is this number right here. And notice dBH correlated with height is the same as height correlated with dBH. Well, this has been the Introduction to Proc Corr in SAS tutorial. If you have any questions, please ask or watch this video again. Welcome to the Introduction to Proc Reg in SAS tutorial. In this tutorial, you will learn how to run regression in SAS. The procedure is very simple, however, you just need to pay attention to the syntax. Now, I've already imported data into SAS, and I'm going to use the forest dataset, which I've used in previous tutorials. If you need to know how to import data into SAS, please go back and look at the Introduction to Importing Data into SAS tutorial. Alright, to start, I'm going to use Proc Reg. That is the procedure that you would use for regression, and that's what it stands for, is regression. The data set that I'm going to use is forest. Remember to put a semicolon at the end of every line. The second line, I have what's called a model statement, which comes in handy later if you take other classes or you want to do more advanced analyses. But for us, we're going to stick with a simple one. We're using the forest data set, and we wish to relate the height of a tree, put an equal sign, so the height is the dependent variable. On the other side of the equal sign, on the right side of the equal sign, you put the independent variable, which is the diameter breast height. Then put a semicolon. After that, put run, and that's all the code you need in order to run a simple linear regression. Go up to the submit button, which is the little running guy, and if you click on that, your output comes out in the output window. Now, the output window has lots of information in it, so you'll need to keep track of all of these pieces of information. First off, you want to look at the number of observations read and the number of observations used. Make sure that those two are the same unless you have some variables at which you know there are missing values. You want to make sure that SAS is using all of your data and using your data appropriately. If you come down, you'll see an ANOVA table, and if you scroll over to the right here, you'll see that there is a p-value associated with the general linear hypothesis. This p-value here is associated with the general linear hypothesis. If you don't know what that means, don't worry about it. Also here, you get the r squared and an adjusted r squared. R squared is the proportion of the variance explained by the regression equation, and the adjusted r squared is a penalized version of that for model selection or model comparison. Down below, you get parameter estimates. So here we have the variable. Notice every regression line has an intercept term. Here's the parameter estimate of 19.33. It gives the standard error of the estimate, which is 1.81. The t-statistic, or the t-value, which is testing that beta 0 is equal to 0, and the p-value associated with that. Here it's 0.001. Now, this would mean, since the p-value is very small, this would mean that this is significant. However, most of the times, we're not interested in the intercept. Most of the time, we're interested in the slope, and that is the slope associated with the diameter breast height. Here's the parameter estimate, 4.39. Here's the standard error, 0.175. The t-value is 25.08. And the p-value is 0.0001, which means that that is a significant relationship. It's testing whether beta 1 is equal to 0. So from this, we can estimate the regression line using the parameter estimates, and we can also test to see if the regression equation, or there is a relationship between diameter breast height and the height of the tree, as well as get some information on how good our model is. How well does it fit using r squared? Well, that is the end of this tutorial. If you have any other questions, please ask or watch this tutorial again. Welcome to the Assessing Your Regression Model in SAS tutorial. In this tutorial, you'll learn how to do basic model assessments on your models in SAS. Now, I already have loaded data in, and I've transformed it as well. This is my Proc Reg data step, or my Proc Reg step, in order to run my model. Now, what I would like to do is have Proc Reg give me other information, not only the model coefficients and the R-squared. So what I'm going to do is I'm going to modify this code in order to have it give me things that I want to look at. For example, I might want to look at the plot of the fitted line against price. So this statement here will plot the data as well as put the regression line through it and give me some summary statistics directly on the plot. Another thing that I might want to look at is the residuals. And the residuals has a special code in SAS. It's R dot against price. This will give me the residuals against the price. That way I can look for any patterns, non-constant variance, etc. I also might want to look at the residuals against the theoretical quantiles. Now what this gives me is a probability plot, a normal probability plot. That's what NPP stands for. The residuals versus the theoretical quantiles. Now if I run this, this is going to give me the regression output as well as 3 other plots which we will look at. Alright, so if I go to my output window, I see the standard regression output. I can get the model coefficients, look at the R-squared, look at tests, whatever. However, I'm interested in the additional information that this gives me. Now notice my first statement I said was going to plot the data, put the regression line on there, as well as give me the equation of the line and other information. And the other information is over here. It gives me the R-squared, the adjusted R-squared, the root MSE, and the number of observations used. And I can look at this and I can say, well, yeah, that seems to fit my data fairly well. But it only gives me one picture, it appears. But if I scroll down, I can see there's yet another picture. Now this is the demand, the log demand versus price residuals against the price. And I can look in here to see if there's any patterns that might be alarming to say that my model is inadequate at fitting my data. And from this, I really don't see a whole lot. Now here is the normal probability plot. This is what I'm interested in assessing whether my residuals are normal because that's one of our assumptions. By looking at this, I see a fairly straight line, which doesn't cause me to be too alarmed about normality assumption. Now this is not a test for normality. It's simply an assessment. An assessment and a test are 2 different things. A test will give me a definite conclusion. This just gives me some idea of whether I should have a problem or not. You'll learn how to test normality in another tutorial. Well, this is the end of the Assessing Your Regression Model in SAS tutorial. If you have any other questions, please ask or watch this tutorial again. Welcome to the Testing for Normality of Residuals in ANOVA Models tutorial. In this tutorial, you'll learn how to determine if your residuals in your ANOVA model are normally distributed. Okay, I've already imported the data, and this data has to do with weight gain or weight loss with certain treatment. Now, if you see I have a class statement, my standard GLM environment, I have a Tukey test on the means, but I'm going to need to add one other thing in order to be able to test normality. I'm going to need an output statement. Now, in a previous tutorial, I've spoken about output statements and how to use them. I'm going to call this one outweight. And in particular, I'm interested in the residual, so I'm going to say R equals resid. And that will put in this file my residuals. Now, once I have the residuals, I'm going to use Proc UNIVARIATE. The data set that I'm going to use is outweight because that is the data set that has my residuals. I'm going to put the normal statement in here. This statement will tell SAS to include tests for normality in my output. The variable that I'm interested in is the residuals, which I've named resid. Then I run it, and this will give me my test for normality. In order to run this, I hit the submit button, which is the little man who's running, and I get a lot of output. I'm not going to look at the GLM output right now. I specifically want to look at my test for normality, and that will be given through the Proc Univariate output. It's just like the Proc Univariate output that was in the Proc Univariate tutorial, except that there's a test for normality in here. Now, it provides 4 separate tests: a Shapiro-Wilks test, Kolmogorov-Smirnov, Kramer-von Mises, and Anderson-Darling. The hypothesis on this test, the null hypothesis, is the residuals are normally distributed. The alternative hypothesis is the residuals are not normally distributed. Now, by looking at these p-values are all large. Hence, we would not reject the null hypothesis. Hence, we would assume that the residuals are normally distributed. So, how do you choose which ones of the 4 to use? I tell people, use the one that you see most often quoted or cited in your literature. All right, this has been the Testing for Normality in ANOVA models in SAS tutorial. If you have any questions, please ask or watch this tutorial again. Welcome to the Testing for Constant Variance and Regressions models tutorial. In this tutorial, you'll learn how to test for constant variance and regression models using SAS and using the Breuch-Pagan test. Breuch-Pagan test looks to see if there's any relationship between the independent variables and the variance, or the residual squared. All right, in front of me, you'll see that I have the Proc Reg statement, my standard regression statement. And notice that here I have a plot. I'm going to plot the residuals versus the price so that I can look at it. Now, this data is the same data I've used in other tutorials. However, it's not the transform data. So, first thing I'm going to do is run this and look at the output. Now, when I look at the residual plots, I look and I see that, number one, there's still a pattern in this data. Also, I notice that there is a lot of variation over here, but as I move off to the right, there becomes less and less variation. So what I want to do is be able to test my assumption of constant variance, and that's what the Breuch-Pagan test will do. I'm going to close this. Here is my standard regression output, r squared of 0.91. Somebody would say, well, that looks great. All right, so what I'm going to need to do for this is I'm going to need an output statement. I've covered output statements in previous tutorials. If you need to learn about those, go look at that tutorial. I'm going to name it demand out, and in particular, I need the residuals. From there, I'm going to use a data step. I've done a data step in a previous tutorial. If you need to learn about data steps, go look at that one. This one I'm going to call demand out 2, and the set that I'm reading in from is demand out. I'm going to need 2 things. I'm going to need the residuals, so I'm going to call it res2 is equal to residuals squared. And I'm also going to need price, which is my independent variable, squared, in order to determine whether there's a relationship at all. And I'm going to run this. And after that, I'm going to use regression again. That's what the Breuch-Pagan test does. Except this time, the data that I'm going to import is demand out 2. My model is going to be residual squared is equal to price and price squared. I'll run this and then I will quit. Now this all together will give me the Breuch-Pagan test. All right, we've already looked at the residual plot. Here is the Breuch-Pagan test. Notice it says dependent variable is res2, residual squared. So this is my Breuch-Pagan test. Also notice that I have price and price2 as my variables. So this is actually a quadratic regression. Now if I go over and look at the p-values, the one that I'm interested in is this one up here, specifically because it tests both coefficients simultaneously equal to 0 to test if there's any relationship. Not what the relationship is, but is there any relationship? And then from this, you see that the p-value is very, very small. The null hypothesis in the Breuch-Pagan test is that the residuals are or do have constant variance. The alternative is they do not have constant variance. In particular, that they're related to the predictor or the independent variable. In this case, the p-value is very small, so that would mean we would reject the null hypothesis and assume that we have non-constant variance. Well, this has been testing constant variance in SAS tutorial. If you have any other questions, please ask or watch this tutorial again. Welcome to the Introduction to Proc GLM in SAS tutorial. Now, I've already imported data into SAS, and I'm going to use the headache datasets, which I've previously used in other tutorials. If you need to know how to import data into SAS, please look at the Importing Data into SAS tutorial. Now, to start off, I'm going to use the procedure Proc GLM, stands for General Linear Model. The data set that I'm interested in is headache. Now this is comparing the difference in relief versus the treatment given. Now for Proc GLM, I'm going to need what's called a class statement. And this is the actual treatment involved. And for our data set, that name is treatment. Be sure to keep semicolons at the end of every line. I'm going to need a model statement. This statement tells SAS what is the independent variable and what is the dependent variable. Our dependent variable is diff in relief. Okay. Notice there's underscores under in this lineup because there are spaces in the SAS header. So if you put spaces in your title of a column, you're going to need to put underscores when you use it in SAS. Now, that's our dependent variable, and we're hoping that it's dependent on the treatment that we've applied, which happens to be headache medicine. We type run, and this is the code that will give us our ANOVA table from Proc GLM. Go up to the submit button, which is the little running man. If we click on that, the output comes out in our output window. Now, my output window is shrunk here to keep it video sized. So this gives us the output that we're interested in. It's actually 2 pages. The first page shows what the class variable is, how many levels it has. There's Advil, Aleve, aspirin, control, and Tylenol, the number of observations read, and the number of observations used. If we scroll down in our output, you'll see that we have the dependent variable, which is difference in relief, and down here we have our ANOVA table. Now, I always recommend people use the type 3 sum of squares. Why I tell people to do that, I'm going to leave as a mystery right now. It's rather a complicated explanation. However, it gives us our treatment, our degrees of freedom, our sums of squares, our mean squares, our F value, and most importantly, our F test, or the p-value associated with it. This is important because it tells me that there are differences among the treatments. Okay? This tells me that there are differences among the treatments because the p-value is very small. Notice that the output also has the R-square. However, in ANOVA, nobody really cares about the R-square of your model. Mostly they're interested in knowing what the p-value is for your F-test. to determine whether there are any significant differences between your treatments. All right, this has been the introduction to Proc GLM and SAS tutorial. If you have any other questions, please ask or watch this video again. Welcome to the Testing for Normality of Residuals in ANOVA Models tutorial. In this tutorial, you'll learn how to determine if your residuals in your ANOVA model are normally distributed. Okay, I've already imported the data, and this data has to do with weight gain or weight loss with certain treatment. Now, if you see I have a class statement, my standard GLM environment, I have a Tukey test on the means, but I'm going to need to add one other thing in order to be able to test normality. I'm going to need an output statement. Now, in a previous tutorial, I've spoken about output statements and how to use them. I'm going to call this one out weight. And in particular, I'm interested in the residual, so I'm going to say R equals resid. And that will put in this file my residuals. Now, once I have the residuals, I'm going to use Proc Univariate. The data set that I'm going to use is out weight, because that is the one, that is the data set that has my residuals. I'm going to put the normal statement in here. This statement will tell SAS to include tests for normality in my output. The variable that I'm interested in is the residuals, which I've named resid. Then I run it, and this will give me my test for normality. In order to run this, I hit the submit button, which is the little man who's running, and I get a lot of output. I'm not going to look at the GLM output right now. I specifically want to look at my test for normality, and that will be given through the Proc Univariate output. It's just like the Proc Univariate output that was in the Proc Univariate tutorial, except that there's a test for normality in here. Now, it provides 4 separate tests: a Shapiro-Wilks test, Kolmogorov-Smirnov, Kramer-von Mises, and Anderson-Darling. The hypothesis on this test, the null hypothesis, is the residuals are normally distributed. The alternative hypothesis is the residuals are not normally distributed. Now, by looking at these p-values are all large. Hence, we would not reject the null hypothesis. Hence, we would assume that the residuals are normally distributed. So, how do you choose which one of the 4 to use? I tell people, use the one that you see most often quoted or cited in your literature. All right, this has been the Testing for Normality in ANOVA Models in SAS tutorial. If you have any questions, please ask or watch this tutorial again. Welcome to Testing for Constant Variance in ANOVA Models tutorial. In this tutorial, you'll learn how to use Levine's test to test for constant variance in ANOVA models. Notice in front of me that I already have the data imported and that my standard GLM code is there to run my ANOVA. The data set has to do with weight versus a treatment, and I have a Tukey's test for multiple comparisons. I'm going to need an output statement, which, if you don't know about output statements, there's a previous tutorial on them. I'm going to call this output out weight. And I'm specifically interested in the residuals because I wish to know if they have constant variance. Now, I'm going to need to use a data step as well. So my data, I'm going to call this out weight 2. The set is out weight. And specifically, I need the absolute value of the residuals. Don't forget your semicolons at the end of every line. Okay, so this data set will have the absolute value of the residuals. And then Levine's test simply runs in ANOVA on the absolute value of the residuals to see if they have constant variance. So again, I'm going to use Proc GLM. My data set now is going to be out weight 2. My class is still going to be treatment. My model is going to be A resid equals treatment. Now, I don't really care to do multiple comparisons here because I'm not interested in which ones are different. I just want to know if they are different. So when I run this, using the little submit button, which looks like the running man, I'm going to get my standard ANOVA output above, but at the bottom, I'm going to have output from SAS on the variable A resid, the absolute value of the residuals. And it ran an ANOVA on it. Notice that the p-value, and this is the only p-value I'm interested in, is 0.6317. Now, Levine's test, the null hypothesis is there is constant variance. The alternative is there is not constant variance. In this case, the p-value is large, so we would assume that the null hypothesis is reasonable, and hence we have constant variance. Well, this has been testing for constant variance in ANOVA models using SAS tutorial. If you have any other questions, please ask or watch this tutorial again. Welcome to the multiple comparisons in SAS tutorial. This tutorial is a continuation of the introduction to Proc GLM in SAS. In this tutorial, you will learn how to do multiple comparisons in an ANOVA setting. Now, we've already imported our data into SAS using the headache data set. We've already typed our Proc GLM statement. We have a class statement and a model statement. We already know that differences exist in the treatments, between the treatments. The question now is, where do these differences exist? And that's what multiple comparisons do. Now, to modify my code that I already have that I've used for the generate the ANOVA, I'm going to just modify this, put in a means statement. I have to put in what means I'm interested in. I'm interested in the means by treatment. This will simply print out the means. But I'm also interested in the multiple comparison. So I'm going to put a slash. Now the slash in SAS says, here are some options that I wish to do with this means statement. And there's lots of them. You just have to know which one you're going to use. I'm going to use the least significant difference. So this is not Tukey's, but this is Fisher's least significant difference test. I could do Tukey's, I could do Chaffee, I could do Student Newman-Cool's, Dunnett's test. All of these are in SAS, and they would all appear after the slash in the means statement. So I put the means, what I'm looking for differences in, which is between the treatments, and what testing procedure I want to use, which in this case is LSD. If I go up and to the little running man, that's the submit button, and I click submit, I get the output in SAS. Okay, and SAS provides me with a lot of output. Okay, so keep that in mind. It says it controls the type 1 comparison error rate, not the experimental wise error rate. So you need to know the differences between your tests before you go and apply these. Now notice that it says comparisons significant at the 0.05 level are indicated by star, star, star. So that's what it's going to use automatically. And you can come down through here and see which of the treatments are different and which of the treatments are not any different. You can see that it's declared that aspirin and Advil are different. Notice the 3 stars. Now notice that it has declared that Advil and Tylenol are not different. There are no stars there. Again, you'll see that Tylenol and Advil are compared again, as well as Tylenol and aspirin. It says they're no different. Tylenol and Aleve are no different, but Tylenol and Control are different. So this gives you a way to check to see where differences exist in your data set by using the mean statement in Proc GLM to do multiple comparisons. Well, this is the end of this tutorial. If you have any questions, please ask or watch this tutorial again.